Thermal and noise isolation are probably the most important aspects of healthy building concept, and therefore it is necessary to set it as one of the main goals in the design process. Of course, it goes without saying that the main goal in the design process is the stability of the structure, and this must not be forgotten at any time. The most complex problems in design of thermal and noise insulation in buildings are structural joints between inner and outer elements. So the aim of this lecture is to show how we can solve this problem by using special products. The most common case of thermal insulation problem is the balcony or cantilever elements, which needs to be structurally connected with the main structure, thus creating the thermal bridge. There are several products, that is, thermal break elements, on the market which can be used to solve this problem. These elements consist of an insulation body, tension bars, shear bars, and compression modules made from ultra-high performance concrete, which altogether behave like a strut and tie system. By placing these elements between balcony and the main structure, we can cut off the thermal bridge while ensuring the load transmission. Another benefit of using these products is that we can combine it with precast elements, which provide more efficient construction process. Thermal break elements are also designed to accommodate to different materials, so they can be used in all combinations depending on the material used for the main structure and balcony. These thermal break elements can also be used on other parts of the structure, such as parapets or canopy roofs. Most producers are giving all necessary information, details, and even software to make the use of these products in buildings design simpler. Noise insulation, on the other hand, is a little bit more complex problem because of different ways of transmitting the noise. Generally, we can differ two cases: airborne noise and structural-borne noise. Problem with airborne noise is easily solved by using quality windows and solid walls, which is also necessary for thermal insulation, so this problem is minimized nowadays. And it can also be solved on existing buildings by simply installing the new windows or adding sound-absorbing panels on the walls. Structural-borne noise, however, has to be addressed during the design process, because solving these problems in existing building can be very expensive or even impossible. While airborne noise is transmitted by air, structural-borne noise is transmitted through solid structures such as steel, wood, concrete, stone, etc. And it is mostly generated by impact or some technical machinery installed in a building. The only way to stop structural-borne noise to be transmitted is to detach the part of the building where the noise is being generated from the rest of the structure. The most critical areas in the building where structural-borne noise can be generated are staircases, elevator and installation shafts, and machinery rooms. Although many people in new buildings mostly use elevators for vertical transport, the stairs are the main part of any building because of the evacuation purposes. This means that the stairs are still being used in some cases, and it is common that their use creates impact noise in the structure. The staircase noise is quite significant if the person is walking down the stairs, because of the higher impact force. Another thing that is important to know is that in most cases, because of good fire resistance, the inside stairs with surrounding walls are made from concrete. Because of this, the staircase walls are often used to stiffen the structure against horizontal load like the wind and earthquake. As mentioned before, the only way to stop structure-borne noise to be transmitted is to detach that part of the structure from the rest of the building. This means we need to detach the stairs from the walls that surrounds them, but keeping in mind that the stairs needs to be supported by that same wall. In order to achieve this, special impact soundproofing elements have been developed, which serves as connection elements between staircases and the walls, or staircases and the plate. The process is very simple. During the construction of the staircase walls, the impact soundproofing elements are installed at the level of intermediate landing. After the wall is finished, the installed elements provide bearings for intermediate landing plate and for the staircase itself. In this way, the vertical load is being transferred from the staircase to the walls, but impact soundproofing elements are stopping the impact noise from the stairs to be transferred in the rest of the building. These elements consist of a plastic box with elastomer bearing inside and special reinforcement dowel which serves as connection for the staircase and intermediate landing plate. Another interesting benefit of using these elements is faster construction, because they enable the staircase walls to be constructed at full story height without stopping at intermediate landing level. Besides detaching the intermediate landing plate, it is also possible to detach the staircase itself by inserting elastomer bearing at the end. This is especially useful when using precast stairs elements, which are often used to speed up the construction process and to save money, because precast stairs do not require any additional final work. Elevator and installation shafts are relatively easy to separate from the main structure, which is often done by constructing double walls around it. In this way, the walls which hold the elevator is completely separated from the plate, because plates are then supported by the new walls constructed around the shaft. This can be time-consuming and costly solution, but it's most efficient, and since there is not much elevator shafts in a single building, it is acceptable. Regarding noise from machinery that might be installed in a building, again, we can have airborne and structural-borne noise. Airborne noise is usually limited by putting the machinery in a special isolated room in the basement or on the roof, while the structural-borne noise is eliminated by isolating the machine with some elastomeric bearings which are placed between the machine and the structure. In this case, the vibration from the machine is not transmitted to the structure. At the end, we can conclude that it is very important to think about these problems in the design process, because most of them are almost impossible to solve after the building has been finished. And we don't need to mention how much the value of the building will be decreased if we don't have proper noise and thermal insulation. It is also important to remember that these are not just problems for the architects, but also structural engineers, because most of these issues needs to be solved during structural design process, so it is necessary that all designers work together to achieve best quality construction. Finally, we must inform everyone involved in the construction process to address this issue in order to achieve healthy environment for everyone in the future. Thank you.